Wonderful. Okay, I think we're going to get started, and hopefully we'll have a few more people join us as we go. Welcome to everyone in the room. Welcome to everyone online. My name is Carly Perry. I'm Managing Director of the Innovation Centre of Excellence in the UK and Ireland, and it's a real privilege to be hosting this session on actions on novel pollutants and preserving biodiversity within planetary boundaries. For anyone who was in the session yesterday, we got a really great recap around planetary boundaries, what the structure is, and we had some really good presentations and discussion around that. We wanted to start today with the big picture and just a little reminder on those planetary boundaries. So, the image we've got shows the planetary boundaries framework. It's one of the clearest visuals that we have warning us of where we're at today. It tells us that Earth has a set of support systems like climate, biodiversity, and fresh water. We all depend on these support systems. It shows us that we are pushing many of them past their safe limits. We've already crossed 6 of the 9 boundaries. That means we're now in unstable territory where nature's ability to support human well-being is under growing threat. Water is at the heart of all of this, as we've heard a lot throughout today. Every environmental crisis, whether it's rising temperatures, declining biodiversity, or chemical pollution, touches water. It's the bloodstream of the planet, and how we use, protect, and share water will determine whether we can stay within these boundaries. We won't be covering all of the boundaries today. We'll be focusing on 2 pressing fronts. So that's novel pollutants like PFAS, microplastics, and pharmaceuticals, substances that weren't part of the natural water cycle and that our systems are struggling to now remove. And we'll be focusing on biodiversity. So that includes biochemical flows. Biodiversity is declining at unprecedented rates, particularly in freshwater systems, and we need to act. But today isn't just about diagnosing this problem, it really is about action. And we heard a lot about that in the opening ceremony this morning. This session's going to explore circular water solutions that go beyond reducing harm. They actually create new value. We'll look at innovations in wastewater reuse, phosphorus recovery, and smarter governance. And we'll ask, how do we scale these solutions equitably? How do we make sure they don't leave anyone or any ecosystem behind? Because this isn't just about technology, it's about justice, it's about resilience, and it's about recognizing that the water decisions we make now shape whether we create a safe and thriving future for us all. So thank you all for being here. We are going to start with a poll that helps us actually frame what you can all do to take action around this. We've got some fabulous speakers and panelists in the corner over here that I will invite once we've got through the poll and we're going through the session. And I will give everybody's background as they come up to the stage. But actually, before we get into that poll, what I'm going to do is just a quick summary of what the session is that we're going to cover. So we've got the role for water for planetary health. We've got innovative solutions for emerging pollutants and regulatory conflicts. We've got global sustainable phosphorus management for climate, food and water security. And a great case study from Mumbai about reimagining wastewater for people and planet. So we've got fabulous speakers that are going to share more on that as context. And then we're going to get into action-orientated. So we've got water-orientated living labs for a water-smart society and phosphorus from sewage and sea with an introduction to PFAS. We're going to have time for a Q&A after that before we then invite up another panel of speakers that will join us. Some questions from me, some questions from you. So if we can ask everybody in the room to be thinking of questions that you want to ask both speakers and panel, and everybody in the virtual world as well, if you can be thinking about questions and sending those through, that would be fabulous. But so, to the poll that I mentioned. So, because this is all about action, the question we want to ask you all is, when you think about your own role, where do you feel best placed to act? So I'm sure many of you have used Menti before, QR code here. We've got 4 options that we want to give you to the question, when you think about your own role, where do you feel best placed to act? Driving innovation and new technology, influencing policy and governance, supporting collaboration across sectors, and raising awareness and changing behaviours. So if you could all please put your thoughts in. This is a new version of Menti that I haven't seen before. I like the wheel. Well, it looks like the top 2 so far, supporting collaboration across sectors and influencing policy and governance. But it's actually getting more balanced as the votes come in. Okay, so I'm going to take around about there, but we will come back to this at the end. So we've got supporting collaboration across the sector as 1, influencing policy and governance as 2, and then we had raising awareness and changing behaviours and driving innovation and technology. So there's going to be an ask for you all when we come back to the end of this session about committing to change in that space. And my hope is that come the end of this session, we've given some inspiration and some motivation to make change. Okay, so we're going to get into the presentations now. So first up, we're going to set the scene with Levke Caesar, who is going to join us online. So Levke is from Potsdam Institute for Climate, and is going to talk us through the role of water and planetary health. Now, I have the clicker, so Levke, if you want to let me know when to change slides, I will.
Yes, thank you. First of all, hello, everybody. It's nice to at least be able to join online the World Water Week. Sorry for not being able to be there in person. And yeah, maybe we can go to the first slide. Just saying that, oh yeah, and one further, please. It's basically impossible to really explain the full role of water in planetary health in just 6 minutes. It's important to consider that when we think about planetary health, water is often like the quiet connector. So going from the high mountain snowmelt to rivers to the deep ocean currents, water is basically everywhere, and it carries energy, nutrients, and often life itself. But it's important to also consider that nowadays it also carries our human fingerprint, and it's changing the health of the whole Earth system. Going to the next slide, please. So I'm leading the Planetary Boundaries Science Lab here at the Potsdam Institute for Climate Impact Research. And the way we are tracking planetary health is through the Planetary Boundaries Framework that you just already heard about. And what this framework does is it identifies the 9 big Earth system processes that keep our planet stable, resilient, and habitable. Last year, we assessed that 6 out of the 9 boundaries are already beyond the safe operating zone, including the freshwater cycle that you can see in the lower left corner. And this year, there's new science out that suggests that also the ocean acidification boundary might have moved in the danger zone, which you can see in the lower right-hand corner. So water really is a current topic when we talk about human imprint on planetary systems. Next slide, please. I want to just go into a little bit the details. As I said, not really possible to do that a lot in a few minutes. But what you can see here is the latest science on freshwater change. So on the left, you see stream flow. On the right, soil moisture. We often also call it blue water and green water. It's not 100% the same, but approximately. And on the y-axis, you can see how much of the world's land area is experiencing unusual conditions compared to a stable pre-industrial baseline. So basically, how much of the land area either is too dry or too wet. The gray line shows the natural variability, and then orange shows what's actually happening under human pressures, like climate change and land use. And the pink line you can see in those plots is the safe zone. And as you can see, the orange line is clearly, especially since the 1970s, above the pink zone. And by 2019, more than 22% of global land was experienced both abnormal stream flow or soil moisture, so really well beyond the safe boundary. Next slide, please. Here we can just quickly tease apart the drivers. So the brown line is the total percentage of land area that shows these changes being either too dry or too wet. And then in this figure, we can separate these into the drivers climate change in yellow, orange, and then other human pressures like land use and irrigation in blue. So you can see while both or all these drivers matter, it's really climate change that is the dominant force. Next slide, please. A similar story is visible in the ocean. As the ocean absorbs CO2, it becomes more acidic, lowering the carbonate ion level that corals, shellfish, and plankton need to build shells and skeleton. And this map here shows the decline in aragonite saturation since pre-industrial times, so really how much more acidic the ocean became. Blue and green show a 10 to 20% loss, while orange and red, and that is especially in the Arctic but also in the Southern Ocean, show declines of 25 or even up to 30%. So this really shows that the chemistry of the ocean has shifted dramatically, putting corals, shellfish, and polar plankton under mounting stress. Just making this clear, ocean acidification is not a future concern, it's a problem that we have right now. Next slide, please. Transgressing these boundaries doesn't just affect rivers or lakes or oceans, so it doesn't just affect the water directly, it really sends ripples through the whole Earth system. One example, in the Amazon, drying trends threaten the rainforest survival, eroding biosphere integrity. Rivers running dry shrink wetlands and trigger local extinction. And on land, the loss of soil moisture means more frequent droughts, which combined then with heat waves that we often see right now, can tip landscapes into wildfires and ecosystem collapse. On the other side, too much water, for example, floods, waterlogging, and thawing permafrost, can release CO2 and methane. And of course, all these consequences also reach people, especially through food security. Next slide, please. Similar cascading effects can unfold in the ocean. As I said, acidification makes survival harder for corals, shellfish, and sea butterflies, which are all at the base of the food webs. So these stress can ripple upwards, threatening fish stocks and the resilience of the whole marine ecosystem. And this picture here really shows the reality. So on the left-hand side, we have healthy corals, then bleaching in the middle, and a dead reef on the right-hand side. And while this is mainly triggered by heat waves, it is acidification that makes it much harder for reefs to recover from those heat waves. So as ocean chemistry shifts, the ability of the ocean also to absorb CO2 can weaken. This again then is eroding one of the Earth's great climate stabilizers. Next slide, please. With this figure, I just really want to emphasize that the water cycle is a connector of everything. So it connects land, freshwater, and ocean into one integrated system, meaning that what happens on land doesn't just stay there. Nutrients from farming can fuel algae blooms, plastic flow into rivers and seas, and greenhouse gases reduce the ocean's capacity to absorb CO2. So all these effects basically mean that the freshwater and ocean change are happening right now, and they are, on the one hand side, interconnected with each other, but also tightly connected with the rest of the planetary boundaries. And that means, going to the last slide, that water really is at the heart of planetary health. And the signs are clear that this system is under stress. So I actually think it's really nice that the session today then will dive deeper into a few examples of these linkages from nutrients to pollutions to biodiversity, and then explore how we can actually restore a safe operating space for humanity. Because simply said, protecting water means protecting our planet. And yeah, if you want to learn more about what we do at PIC, you can please check out our Planetary Health Check website, and we will release this year's Planetary Health Check in a couple of weeks. And with that, I thank you and give back to the room.
Thank you, Levke. I think that was a really informative, if what, a little startling introduction to the session, but hopefully we are going to inspire you and build hope throughout the session. So next up, we're going to be hearing from Stefan Wollquist, who is International Sales Director at Chromafora. Stefan's going to be sharing his wealth of experience on innovative solutions for emerging pollutants and regulatory conflicts.
So, hello. Allow me to introduce firstly the Water Europe Expert Group of Zero Pollution and Health. Our mission is to bridge science, innovation and policy to reduce pollution and protect both ecosystems and human health. We focus our work on three main areas. First, we promote research and innovation. Secondly, we stimulate development of solutions and best practices. And thirdly, we ensure knowledge transfer, because evidence-based research must not remain in academic journals. It must reach policymakers, operators, and communities, empowering them to take action with the best available science. In short, our group provides a platform where expertise and practice meet, enabling Europe to move closer to the vision of zero pollution for healthier people and a resilient ecosystem. I'm going to talk about what's called contaminants of emerging concerns. So what is that? These are chemicals or substances that have been detected in the environment, water or soil or air, but are not commonly monitored or regulated and may potentially pose risk to human health and the environment. These contaminants are emerging, not necessarily because they are new, but because their presence in the environment is newly discovered or better understood. Their potential risks are just becoming recognized by scientists and regulators, and the analytical methods has been improved, and hence you can detect them at lower concentrations. And you have some example of CECs. So these CECs, they pose risks that go far beyond individual pollutants. First, the substances accumulate in our aquatic environments. They may exist in trace amounts, but over time, they will build up, creating growing and persistent burden for the environment. Secondly, CECs are rarely acting alone. When combined, their effects can be synergetic. Small concentrations of different substances can interact, amplifying toxicity and making their impact far greater than the sum of their parts. So this is not a good thing. This leads directly to a loss of resilience in the ecosystems. Aquatic system that once could adapt to gradual change becomes fragile. At a certain point, the risk crossing thresholds that trigger sudden collapse is irreversible. These consequences are severe. CECs can alter water services, undermining the supply of clean water, safe irrigation for agriculture, or even quality of water for recreation. They also threaten biodiversity, disrupting food chains and weakening ecological balance. Species that are particularly sensitive to contaminants may decline or disappear, leaving ecosystems destabilized. And of course, the risks do not stop with nature. Human health is at stake. CECs can accumulate in food chains and drinking water, exposing communities to substances linked to hormonal disruption, cancer, which you have probably heard about when it comes to PFAS, and other serious health effects. So, what's the challenge then? Well, monitoring CECs are challenging due to the diversity of pollutants and limitation in detection sensitivity, especially at trace levels. And as you might know, we have set a drinking water limit at 4 nanograms and for PFAS. And 4 nanograms just a couple of years ago was detection limit. So we are really on the boundary. We must translating these lab data into field conditions is difficult because real-world complexity often blurs the link between contaminants and ecosystems. Monitoring must go beyond identifying substances. We must trace their origins, so we find the hotspots, the points where the contaminants are found, sourced, so we can limit the runoff to water and air. So, key questions. What happens when water is used and reused over time? Well, contaminants accumulate, and without effective removal, water quality will deteriorate. And we've seen this already. If you look at the PFAS level, as an example, in the River Rhine, that is going up and up. We lack sufficient data on long-term interconnected risk. Predictive tools are needed to understand how contaminants persist, interact, and build up in the environmental across time. So, how do we solve this problem in 2 minutes? So we have to prevent the pollution at source, and this is very important. Now the legislation is put at the user, at the water, where we produce the water, which is not the correct way. We should have the polluter pay principle working. We also need legislation because people will not stop using PFAS or using PFAS in their production if we don't legislate it. When it comes to governance and innovation, we must enable the innovation, not just regulate after the fact that we have cancer all over. We need to cross-sector collaboration because bringing together science, technology, policy, and industry to proactively manage emerging contaminants or threats. The strong governance framework will accelerate the adoption of new solutions and ensure that innovations translate into real-world environmental benefits. Act now, not later. Costs are already high, and they will grow exponentially over time. Yeah, I'm done. Thank you.
Thank you, Stefan. Appreciate it's impossible to solve in 2 minutes, but I love your attempt at starting the conversation there. So it's great that we're starting to move more into solutions and action. So next up, we're going to go back to the virtual world. I'd like to welcome Will Brownie from UK Centre of Ecology and Hydrology. He is Senior Science Project Manager and is going to be sharing more on global sustainable phosphorus management for climate, food and water security. And Will, I have the clicker, so if you say next slide, please, then I can move you along. Ba-bow. No Will? Okay. Is this where I need to do the interpretive dance? Okay, so in which case we will speed on to the next speaker, so Rupali. So to finish this content and theory stage, we're going to hear from Rupali Deshmukh with a case study from Mumbai. So Rupali is country manager for India at IVL, the Swedish Environmental Research Institute, and is talking us through a circular shift, reimagining wastewater for people and planet. So welcome, Rupali.
Thank you, Kelly. Thank you. So, we talked about different pollutants entering the water bodies. My colleague Stefan has mentioned about the solution in 2 minutes. It was really good. So let's see how it has been adapted in city Mumbai. An earlier speaker who couldn't join was going to talk about the phosphorus. Phosphorus is nutrients are very important for food production, but when it comes in excess when it enters the water bodies, that kills the ecosystem and destroys the biodiversity loss. So I am now going to show or focused on how these challenges are being addressed in a city, Mumbai, India, and what type of result they got it. Oh, here. So, Mumbai is the economic capital of India, is emerging as a model for SDG 6, that is clean water and sanitation. The government of India is investing heavily through different national missions like Amrut 2.0, Swachh Bharat Mission, that is Clean India Mission 2.0, and Jal Jeevan Mission. And what is the aim? The universal clean water access, reviving or restoring their rivers, coastal areas, and building a circular water economy. What is this today's situation? So Mumbai generates around 3,000 MLD of wastewater every day. But what pity, they just treat 50% of it, and that too in an outdated old facility, which offers only the primary treatment. and rest is dumped into the water bodies or the Arabian Sea. And what are the consequences? It is impacting the human health, public health, like waterborne diseases and all. Then also because it is contaminating their freshwater rivers, water scarcity they are facing hugely in city. And of course, driving a marine pollution and biodiversity loss. And to overcome on this, there is a good initiative by Government of India is driving a major reform in city Mumbai, investing for a cleaning sea, safe public health, and solution to a water scarcity. So as a first step, Mumbai is a coastal habitat like a Shivri Mehul Creek, hosts a rare species like flamingos creek and the rich marine life, but faces threat to due to the pollution and due to the industrial activities. So they have started bioremediation initiative to revive this ecosystem by naturally cleaning the polluted water, restoring the mangroves, and boosting the biodiversity. As I have already mentioned, Government of India investing heavily. Mumbai is upgrading its wastewater system with advanced tertiary treatment in all these 7 STP. And this STP will have the 50% water reuse. Sludge would be converted into a Class A biosolid, capture of biogas for the power generation, and these are all supported by public-private partnership. And what does the future look like? As I already mentioned, the future looks really promising. The treated water would be suitable for non-potable use, like for agriculture, gardening, and industrial cooling. Also, they are going for the groundwater recharge. And they are also investigating how this water could be used for the potable use. That sounds promising, isn't it? And this initiative will impact 24 million people of city Mumbai. 24 million, guys. It's a big number. We are just 10 million in Sweden. So it will benefit a big population. And by improving the health, sanitation, easing the water stress through a reuse, it will create a job, boost the circular economy, clean the river sea, and restore the marine ecosystem, and cut down on the emission. So I would say paving the way for the greener and more water-secure Mumbai. And I'm extremely proud because IVL is working as a project management consultant and contributing to Mumbai's water resilience through technical collaboration on Mithi River Restoration Project, Bandra Worli Wastewater Treatment Plant Project, and those are really big wastewater treatment plant I'm talking. A 500 MLD, a 350 MLD, so big, huge impact IVL is trying to create in India together with Government of India. So again, the Mithi River Restoration Project focuses on lowering the flood risk by improving the flow, restoring the wetlands, creating the green buffer to absorb the rainwater, and boosting the climate resilience and reducing the water clogging. What message I want to give here? The Mumbai is transforming its wastewater challenge into a blue-green opportunity. With a bold investment from Government of India and public-private partnership and the support from the organization like IVL, it shows the power of circular water system. And I would like to say, together, we are not just treating the wastewater, we are shaping the sustainable future. Thank you so much.
Thank you, Rupali. I think that was a change case on a very inspirational level, so thank you for that. Very happy to say that we have Will back online. I hope we have Will back online. So Will, if you can hear me, I have the clicker and I can click through your slides. Are you there?
I am. Sorry for the confusion.
floor's all yours.
Wonderful. Thanks very much. So I'm talking about sustainable phosphorus. I don't know if people in the audience know much about phosphorus, but we have a global phosphorus emergency. It's significant, it's urgent. It's a global crisis. It's planet changing. It's contributing to climate change, food crisis, water crisis, the current financial crisis. But when I mention phosphorus, quite often people say, well, what is phosphorus? So equally intimidating is that most people seem unaware of the scale of the risk. Policy attention is minimal. There's no global strategy. There's no UNEA resolution. There's very little SDG focus. National policies are often quite fragmented as well. But it's not all doom and gloom, because addressing phosphorus sustainability in its nature of a myriad of impacts is also an incredible opportunity, because if you fix sustainable phosphorus sustainability, you can also fix multiple global issues. So what's phosphorus and why should we care? Phosphorus is essential for fertilizer. Without fertilizer, food security collapses. Let me have a look at the slide. You can click through the slides if that's okay. Yep. Keep going. Yeah, there we go. There's the triple things. There we go. That's the right slide. Thanks very much. Phosphorus mainly comes from phosphate rock for fertilizer, but here's the kicker. 4 countries hold 80% of it, with Morocco and Western Sahara alone at 70%. That means most countries depend on imports. But production isn't the same as reserves either. So China has just 5% of reserves. And for example, in 2024, they made 40% of the global phosphates for the market. The last few years have been very volatile. In 2022, fertilizer price surged up by 400% due to the pandemic, to trade wars, the Russian-Ukraine war, fuel hikes, export bans from China and Russia. And as far back as 2009, 1 in 7 farmers couldn't access enough phosphorus to grow their crops. So the situation is now worse, which is contributing to the sort of global food crisis that we're in. At current mining rates, Russia, China, and the US could exhaust their phosphates in under 45 years. That will leave Morocco as the potential gatekeeper for global food security, and that's a major challenge for one country. So how do we get to water? So that's too little phosphorus, and we have too much phosphorus. It's dangerous for our water health. So excess phosphorus in rivers, lakes, and seas fuels algal growth, which can explode into these toxic algal blooms, which I'm sure you've seen on the telly or in reports. These algal blooms kill aquatic life. They wipe out fish populations. They destroy fisheries and aquaculture, and they can poison our drinking water. So the main culprits are fertilizer overuse, poor sanitation, and sloppy management, plus government inaction. The impacts are already severe and in some cases irreversible. Freshwater biodiversity has plunged by 83% since 1970 due to phosphorus in large pollution. Over 25% of freshwater species are now threatened. There's major marine dead zones in the Baltic Sea, in Chesapeake Bay, the Gulf of Mexico. Even the Great Barrier Reef is being impacted. And humans feel it too. Half of the world relies on aquaculture for 20% of their animal protein, and algal blooms are poisoning our drinking water, even in the rich countries. In 2014, for example, 500,000 Ohio residents were warned not to touch or drink their water because of algal blooms in Lake Erie. Phosphorus pollution is also expensive. Cleanup costs are in the billions. 87 million was spent on the 2008 Olympic sailing event, bloom in Beijing, for example. That's one bloom that cost 87 million. At the moment, people aren't dealing with the blooms. At the moment, society pays through loss of ecosystem services. And then we come to climate change. Climate change is making the algal blooms more common, and those blooms are making climate change worse. When phosphorus-rich algae die, they release methane, which is a super potent greenhouse gas. So you think of these polluted lakes as giant cows constantly belching methane. That will give you an idea of what's happening. In fact, methane from lakes already accounts for around 20% of global fossil fuel emissions. That could double by 2050. The social cost of that, up to 81 trillion. So since 1980s, algal blooms have been worsening, especially in Asia, South America, and Africa. Between 2002 and 2010, 40% of river basins globally had phosphorus pollution beyond healthy limits. That affects 90% of the global population. Some lakes are so polluted, they're actually catching fire. like in Bangalore, which was known as the City of Lakes. And you actually see those lakes catching fire every so often. Don't know if that's in the slide. Yeah, there we go. That's the city on fire with the lakes. So looking ahead, eutrophication could rise by 20 to 100% by 2050. And by 2100, lake methane emissions might equal more than half of today's fossil fuel emissions. The economic costs are enormous, between 7.5 trillion and 81 trillion by 2050, dealing with that. So in 2019, 500 scientists came together, signed the Helsinki Declaration. This led to a baseline report on phosphorus and what to do. And that's what I encourage you all to go out and read if you can. It was written by 100 scientists from 21 countries. And it writes out not only the challenges I've discussed, but many of the solutions. And of course, these solutions are interlinked. This is increasing phosphorus recycling, improving use efficiency, and reducing phosphorus losses. Equally, so are the benefits being interlinked. By recycling phosphorus, for example, we can buffer against phosphorus supply risks, which secures food security and protects livelihoods, while simultaneously reducing phosphorus pollution and reducing contributions to climate change. Therefore, it is no surprise the solutions will be most effective if they are delivered in an integrated approach. This means phosphorus stewardship not only throughout food production and consumption, but also across whole regions and internationally. The Our Phosphorus Future report I just mentioned proposes a global target to work towards. This would be reducing 50% of phosphorus pollution and a 50% increase in recycling of phosphorus by 2050. Can we achieve it? Technically, yes. Will we? Probably not. But it's something to start with. There's a lot of green shoots of progress that are starting, and we call for all nations to commit to real-time assessment of their phosphorus vulnerability, accelerate a global transition to a more circular phosphorus economy, and accelerate intergovernmental cooperation as a catalyst for change. Thanks very much.
Thank you, Will. I'm pleased that we managed to connect with you. That was really good context about phosphorus in this conversation. So we've got two more presenters before we open up to questions. So just a reminder to everyone online in the room to be thinking about questions for our speakers. Next up, pleased to welcome Andrea Rubini, who is Director of Operations at Water Europe. And Andrea is going to share more on water-orientated living labs for a water-smart society.
Good afternoon. Thank you, Kali, for the introduction. I'm honored to be here today representing Water Europe. And, I'm speaking about water-oriented living labs, which is not a technological solution. It's an approach, it's a methodology, it's a system. And let's see why. So, we are speaking about planetary boundaries, and it's important that we frame the challenge. So, we have exceeded our planetary boundaries. We have exceeded, and what is clear today that incremental governance and incremental improvements, even in terms of technology, doesn't work. So we need really a systemic and inclusive solutions and approaches to avoid that planetary boundaries will be more and more broken and breached. What we propose is a solution. It's called water-oriented living labs. It's a solution in terms of being an inclusive and systemic approach, because they are territorial, real-life environments. So they are real places in which the actors of the territory, making reference to a well-known model which is called the equitable helix, sit around the same table, and they move. They start in looking for innovative solutions, and they move in the water-oriented living lab from theory to practice. So it means that they validate the technologies, they look at new governance models, and they apply new governance models, and of course, business approach under, which is important, real conditions. So it is not theory, it is practice in real-life environment. Also because I repeatedly say that water is a global challenge. Everybody says that, well, we have a challenge with water. I'm from South to north, to east to west. But then in the end, we need to address water challenges at local level, because water is a local challenge. So also to say that water entity labs can really help a lot in terms of being the real ideal place for working on regulatory learning, and they can really evolve rules and best practice across water management, including, as we said, pollution, resource efficiency, and innovative water technologies. So we advocate, and as Water Europe, for achieving a water smart society and economy. And Water Entity Labs really contributes to build a water smart society, because it's a society where the value of water is recognized, where all the resources are managed and water scarcity and pollution are avoided, and the water resource loops are largely closed. This is, in order to support the achievement of a circular economy and resource efficiency. At the same time, we need to work on the resilience of our systems and because of climate change and demographic impacts. And last but not least, Water Entity Labs work, to achieve a water smart society and economy by using an inclusive and sustainable water governance. Our Water Entity Labs can tackle planetary boundaries. Equity. Water Entity Labs is a place where people count, and people can say what they have in mind, and they can apply systems, methodologies, technologies. So it's a way, to engage community. Water Entity Labs can check and test for emerging contaminants. Water Entity Labs are real-life environment in which biodiversity can be followed up, and on a real case. Circularity. Water Entity Labs can support the circularity because they can put together all the actors of the territory, where NATO-based solutions can be tested and scaled up, and they can work, in the European Union and transnational perspective in order, to support the European and global goals, and what is important, pooling human and financial resources across border. There are also examples of Water Entity Labs, but I would like to speak here about also initiatives that are supporting Water Entity Labs, like large partnership, like Water for All. Water for All is a EU-funded partnership which engages 36 countries in Europe, beyond Europe, and one of the pillars of Water for All is supporting the demonstration of innovation through water-oriented labs. And in order to do that, we have been creating, a network of water-oriented labs, which are for real leading examples on how to address water challenges on a territorial context, and we have been able, to support this network, to establish an important dialogue in order to exchange experience and start, scaling up the solutions that have been tested in several places in Europe and beyond Europe. Another project, for instance, this is a project that supports, the Water-Oriented Labs approach, is this ideation, which is quite, an important approach because it wants, to build a digital twin of inland waters interoperable with the DTO, with the digital twin ocean. So you can see that, the scenario is becoming large, but at the same time, we focus we pay attention, we focus on water-oriented living labs and real life environment. So it's a closing message here. Sorry. Water-oriented labs are really concrete accelerators to bring water back within the planetary boundaries, because they work on real challenges in real environments. Can link local innovation to the European strategies and beyond that, as far as being as a reference the water resilience strategy, and the water-oriented labs connect vision to action. And this is particularly important because otherwise, we get lost, into the question how to find a solution, but then the solution, once that we have an idea of how to implement it, must be implemented. The water-oriented labs can really support in scaling up feasible solution for a water smart society and economy. Thank you so much.
Thank you, Andrea. And I love the principle of accelerating vision to action. Talk less, do more is one of my favourite sayings. So great to see that. Okay, so final speaker in this section before we open up to questions. So I'd like to welcome Per Larssons, Chief Sustainability Officer at Randcells. So Per's going to talk us through phosphorus from sewage and sea with an introduction to PFAS. Thank you.
Thank you so much. And I will also come back to a little bit of what was discussed yesterday, but also today, of course, to relate the challenges with solutions. So I will now provide solutions, hopefully. My company, Randcells Group, originated from 1881 when we started as a transport company. Today, we are a waste management company, but we understood in 2015 that that will not continue forever. The circular economy will make sure that we have no waste in the future. So we went into crisis mode and said, what will our role become in the future? So what we did is that we decided to use the planetary boundaries as the guiding tool for us to understand where should we develop innovations. And with the background from 1881, when we transported latrines from the inner city of Stockholm to the farmland surrounding Stockholm, of course, phosphorus and nitrogen were natural to make sure that we can try to understand what we can contribute with. So we have now solutions to recirculate nitrogen, phosphorus of high quality, and I will come back to that. So the planetary boundaries has been in the heart of our business development. When it comes to the nitrogen challenge, I can recall the discussion yesterday, and it was also mentioned that the cost only for the Netherlands per year are 14 billion euros. Due to that, they have too much nitrogen in the wrong place in the water. Of course, it is a lot are because of the farming industry, but everything counts. And every action that can be done to reduce that will, of course, generate more income. In this example, we have the House of Lords, UK, that has undergone a report or investigation about what could UK do to reduce the challenge when it comes to nitrogen in UK. And the report finally came in July. We have been able to contribute. And the conclusion is we need to go circular. So now we come to the solutions. We have developed an innovation that can recirculate nitrogen directly in the reject water phase. It means that we, in this case, can take as much as 30% of the total nitrogen load and directly produce a nitrogen fertilizer. In many cases, the wastewater treatment plant doesn't need to have as much capex investments. We can maybe reduce it from 200 million euros to 10 million euros. We will produce a nitrogen fertilizer that the wastewater treatment plant can sell. They can use less energy because it's a chemical process, and we can eliminate the risk of laughing gas emissions. We can also make sure that they produce more energy. Still, we have a challenge, because when we talk with the wastewater treatment plant, they say, well, we can't sell things. That's not our role. We are only doing bad things less bad. So here we need a change. We need to make sure that wastewater treatment plants have the obligation to produce resources, and then it will, of course, reduce the total cost of the society. On the right-hand side, we have our phosphorus innovation. And when it comes to our phosphorus innovation, I will come back to Rupali. I was in India last year in March, and I met with the SIPRI representatives from 2 cities, and they're now starting to install wastewater treatment plants. They asked me, but what should we do with the sewage? It's so contaminated, we can't spread it on the soil. What we have developed is innovation that produces a really high-quality end product. In 2015, when we started it, it was banned to be used even as a fertilizer. In 2019, EU changed the regulations, so 2022 is allowed to use recycled phosphorus as a fertilizer. This June, they also confirmed that our phosphorus can be sold for organic farming. That's, of course, a dramatic change because then it can have a higher price. And what's happening now is that last week, Sweden said, we are now pushing EU to make sure that you can sell it as a feed phosphate. What will happen then is that the phosphorus price will be so high, so the cost for the cities will go from a cost to an income when it comes to treat sewage sludge. Suddenly the phosphorus has a value. The more phosphorus they collect, the more money they will earn if they also invest in this one. Besides the phosphorus, we are taking everything from the sewage. So the silica can be brought back and replace cement in concrete productions. The iron chloride, aluminum sulfate are brought back. And this is happening for real. we're now building our 2 phosphorus plants, one in Germany and one in Sweden. At the same time, we are now preparing to make sure that we can sell the phosphorus as a feed phosphate. That means that we also now already have a partner in Canada. We can't sell it in Europe for the moment, but we're opening up also in the North American market. And my question to the EU Commission is, of course, do you want us to build the next 50 factories in Europe or outside of Europe? So let's have this as an open question. So the first plant will be up and running from 2027 and the next from 2028, but we already have a pipeline of plants, and hopefully in Canada we might have one from 2035. Phosphorus is crucial. Phosphorus is very important, but phosphorus also are in other places, and one of the places is in fish farming. Here we have now a project ongoing. We already are collecting fish sludge. We already send it to biogas plants, but now we do it in a product, we will do it in a large scale. And it means that we can then hopefully also boost the food production in the aquaculture, meaning that we remove the biggest problem for increased food production. So in 2029, I hope to come back and give you a present, a complete circular system where also we then produce the phosphorus and bring it back as a feed phosphate. The amount of phosphorus in sewage sludge after incineration are 9%. That's 5 times as much, or more than 5 times as much as we have in our mines. The phosphorus content in the fish farms are 16%. So understand, it's a high value, and we can sell it as a feed. It really grows. So a last thing I like to make sure that I also mention, we like to make sure that the wastewater treatment plant doesn't only become resource plants when it comes to nutrients. We also believe it's important that the water can also be reused. And of course, the PFAS issue is crucial. And we need to remove it where it is a problem. Now we are moving the problem to the wastewater plants, and it becomes a headache because then the concentration are much lower. We need to focus on the hotspots. In 2018, we understood that this will be a challenge for the waste industry. So therefore, we make sure that one of our companies were focusing on developing innovation for recovery of phosphorus, for PFAS. And Stefan Wallqvist, that presented here, are now representing Chromafora. They are partly owned by us and has this innovation. European Investment Bank has now also giving us a support with 22.5 million euros to expand this innovation. The unique thing with this one is that they concentrate the PFAS 1,000 times, and we only get the PFAS. And we get the PFAS to a very high degree, long one, short one, and even ultra short. And we target the hotspots. And then suddenly the wastewater from a wastewater treatment plants, or resource recovery plants can also be used without risk or with lower risk. Here we have concrete examples of innovations, and I hope we can move in this direction going forward. The potential is global. I love to have these factories in all major cities around the world by 2050. Thank you.
Thank you, Per. Great to see such a well-rounded solution there, and I think covering a lot of the themes that we're talking about today as well, whether it's policy or collaboration, innovation, all coming in to one. Okay, so we have 7 minutes for some questions to our speakers so far. What I'm going to do is take one from the virtual world, if there is one there, and then come back to the room. If, when asking a question, if you can say who it's for, and because we're a bit short on time, I'm going to ask speakers to be poised and ready to come up on stage to answer a question if your name is mentioned. So, to the team at the back of the room, are you able to let me know if we have a question from the virtual world? Okay. In which case, any questions from the room? Fabulous. We've got some roving mics, so we'll wait for that to get to you. And if you can let us know who it's for, that would be fabulous.
Yes, it's a PFAS question, so for either of you to answer. I'm Amelia Wenger from the Wildlife Conservation Society. I just am curious, when you go, I understand that obviously PFAS is removed from the waste, but what do you do with the membrane filter that's concentrating the PFAS. What's the sort of process for then safely destroying that?
So we're not in the dirty part of the wastewater treatment plant. So we're upstream, hopefully, at the process plant where the PFAS is let out in the wastewater. So you can't use that kind of membranes that we use for separating in how do you say, dirty water where you have solids. So I think that's what you're asking about, if we can use the membranes in solid containing.
No, more like.
If we can just use the microphone so the virtual people can hear you. Thank you.
Maybe then more of a question for you in the resource recovery plants is like when you are going to, in the last slide that you had there and you showed the membrane filtration as the sort of last step, chemical membrane filtration, clean water. I'm just wondering what the process is then for safely destroying the membrane filter that is concentrating the PFAS.
Ah, you mean the contamination of the membranes?
Of the membrane.
Aha, okay.
Yeah.
Then it's, but that's normally into incineration, but maybe Sarah has another one.
I can say that the only solution really that works today is incineration. And, but of course, and also when you produce the membranes today, it contains PFAS. But the thing is that the good they do is that then they collect the PFAS. And of course, you need to have a safe method, probably over 1100 degrees. There's a study from Japan that says 1050 degrees and they can destroy it. But a lot of things are happening. But on the, we can talk with when we talk about the PFAS solution we have, we can also use it in the clean water perspective, and then it's after ultrafiltration, because then you take everything that comes out, and then the technology can concentrate it, and then the cost for the cities to treat their PFAS and remove it are much lower. So it's a concentration technology that Chromaphora has. So that was a. Have I covered your question now?
Yes, thank you.
Good.
Thank you for the question. Thank you, Per. Other questions from the room? Just over here. Thank you.
This is also for you, Per. When you're talking about your work, you're focusing a lot of effort on wastewater treatment plants, which makes sense, right? Because that's where a lot of the pollution sourcing is coming from. But when we've had this session, there's been a lot of images of places in nature that have a lot of phosphorus concentration. And you were talking about how, gathering the phosphorus and the nitrogen, it becomes a source of income from a waste stream. Has your organization thought about extracting the phosphorus and nitrogen in places where they're out in nature and they're just very, very concentrated in these hotspots as opposed to a point source of coming out? And also, do you think that that could be sort of a business opportunity in the future, that it's sort of harvesting, instead of making use of a waste stream, it's taking away a collective waste that is out there somewhere and turning it into a product for farmers, for instance?
We can take the Baltic Sea as an example. It's polluted with a lot of phosphorus that are deep into the soil. The problem is that it's very low concentration compared to what you have in wastewater treatment plants. So if you decide that we need to remove it, you can do that. If you incinerate it, yes, definitely we can treat it. But the thing is that we should avoid to polluting the Baltic Sea more. So there, the wastewater treatment plants or the resource recovery plant will be important. So then we should avoid doing more bad stuff. So that's my answer.
Thank you.
Thank
But it's possible to use, yes.
Got time for one more question from the room, right here. Thank you.
I am Isaac Chafura from Malawi, NGO called DNE. I was very much interested in the water-oriented living labs. And that presentation brought me some hope that there was effort to work with practitioners, because I'm coming from the NGO sector, working with the farmers directly. I'm happy to see that some of the points presented here is that the walls are trying to bring together the science and the practice by working with civil society organizations like mine. And then I also followed it that they also focus on the implementation of technologies that work. And the DNE has a technology that harvests most water that we receive through rain as we implement with the farmers. That action itself is done through what we call deep bed farming. And after harvesting the water in full, and then it allows water to infiltrate in the soil, making it go through the natural ways of purification. So my question is there a room that probably such an intervention like ours can be supported, and then we scale out so that more and more farmers can benefit from this natural way of purifying the water, and then it becomes cheaper even to use by water bodies and the like. Thank you.
Andrea, we have 1 minute for an answer to that. Apologies.
I'm here. So many thanks for your question. Water and Utility Labs are bright examples that their characteristic is to be adaptive. So we don't have so much time, but we can speak after the session if you so wish. So I can bring you some examples, and we can go deeper into the discussion. Thank you so much. Thank you.
Fabulous. Thank you. Join me in thanking all of our speakers so far. Okay, so we're going to move into the panel session part of the day now. So I would like to welcome to the stage Anna Soldholm, Executive Vice President, IVL, Swedish Environmental Research Institute, Diana Kopansky, Head of Freshwater Unit at the UN Environmental Programme, Dirk Kroll, Executive Director, Water Europe, and Leah Jones-Crank, Assistant Professor, University of Waterloo, Ontario, Canada.
How do you want us to stand? Like
Go to, and I'll stay in the middle, otherwise I'm going to mess with your microphones. So I'll try my best not to do that. So, Diana, you've been busy today. And I think we've heard a lot of your big messages today, but what I wanted to do was just start with this session specifically around what do you think is needed to make a shift on pollution, and in particular tackling the challenge in wastewater?
So I'm really happy to be representing my colleagues who are specialists on this topic. As you know, I've been representing sort of broadly UNEP's work, but we have indeed a lot of great work going on that we'd like to share with you, and that includes some of the secretariat work that UNEP does to bring the Global Wastewater Initiative together. We're engaging over 200 members, governments, researchers, and NGOs, and that is, bringing this collective of knowledge and experience, technology from private sector as well, and making it more well known. I think that a lot of these technological innovative solutions maybe stay where they're born and bred or invested in, but really what we're trying to do as UNEP is to actually bring that to stakeholders around the world. And we do that through, we do that through training stakeholders on how to monitor and improve water quality. We also do showcase and pilot projects to look at sustainable wastewater and water management. And we also look at nutrient recovery. I think that that's a really important point, that actually can look toward recovering pollutants, which are actually quite often resources. So circularity is a really important piece for us. We know, though, that the world generates an estimated 380 billion cubic meters of wastewater annually. I want to give that global perspective. 48% of global wastewater is released untreated into the environment. So there are not even recovery plants or wastewater plants available around the world. And by 2050, global wastewater volumes are projected to increase by 24%. That withstanding is that treated wastewater could actually supply up to 10% of the global irrigation water demand, boosting water security in stressed regions and also creating an opportunity to recover these valuable nutrients that are often just swept or washed away.
Wonderful, thank you. And I think there's some common themes that we're starting to hear through all of this, and it's about raising awareness of solutions that already exist, about collaboration, about policy, about innovation. What I wanted to come on to is I think we've probably got a couple of panel members who have quite similar interests and areas of experience. So Dirk, I was going to come to you next because I know that you've been strongly advocating for systemic approaches to water management. For anyone who doesn't know, in the UK recently, we've just had an independent water commission who have just recommended systemic approaches to water management. So we have a new water strategy coming that will help to do that. So what I wanted to start with was, from your perspective, what governance or regulatory shifts are most important for us to move to this systemic approach?
Well, there we see, I mean, as Water Europe, we really believe that water cannot be dealt with in isolation. Yeah, and I think to stay a little bit within the narrative of this session, I think water is really the bloodstream of our planetary boundaries. Yeah. So there what we need is a really strong governance, yeah, that takes into account our systemic criteria, but also is looking ahead at what is going to come and is doing it in a very well integrated way. Now we see a number of shifts that are necessary there. I think firstly, we need to make sure, and it's already mentioned before, that we need an upstream approach. Yeah? So we need to address, I would say, the potential pollution at source, yeah? Not at the end where we have end-of-pipe treatment, which are usually much more costly. Now, in order to do that, we need a good integration between the different policies at European level. That would then mean the Water Framework Directive, the chemical legislation, but also at looking at the product design rules. That is very important to make it everything very coherent. Then another thing is, I think what is very important, that we really mainstream water reuse and circularity, that it does not remain an exception, but it really becomes normal practice in the context of industrial processes, urban water use, but also agricultural water use. And there we see that we need then, I would say, a number of stimulating tools, which could be, of course, good standards that can always help. Yeah? Financial tools, these are always very important, but also incentives for the uptake of these new innovative approaches. I think that is very important. And lastly, of course, I think we need to make sure that we embed biodiversity in water policy as natural infrastructures, yeah? Taking into account that rivers, wetlands, etc., are not just nice to have, but are essential to the way we manage and operate water in our societies. And there we also need to make sure that we then have a good cross-policy approach between different essential legislations, like we have now in the EU, the new water resilience strategy, in which we will go more in depth tomorrow. So I would advise you to come back tomorrow, and we will explore that more in detail. Yeah, but also the nature restoration law and other types of policies.
Fabulous, thank you, and great plug for tomorrow. And Leah, coming on to you, I think a lot of your specifically collaborative governance experience links into all of this as well. And again, another snippet that I'll go into more tomorrow, but the Independent Water Commission in the UK has just recommended merging our regulators into one, which will include more collaborative governance as well. So it seems to be a bit of a common theme and a shift that is happening around the world. But so from your experience, how can collaborative governance help biodiversity and the situation about PFAS that we've been discussing today within planetary boundaries context?
Yeah, thanks for that question. So I feel like I get to wear a lot of hats at this conference because I'm on the Young Scientific Program Committee, but I'm also an assistant professor and a researcher. So I'm putting on kind of my research hat right now. And I see a lot of opportunities for collaborations between these different sectors as we think about water intersecting with food, with energy, with biodiversity, with climate change. And I think there's both an opportunity, but then a potential challenge that we face. So I'll start with the opportunity. First, we know that water doesn't exist in a vacuum. We know that we have these larger systems together, and we can see evidence of where this level of collaborative governance is leading towards more positive impacts. So for example, some of the work that I'm doing is working in Canada on the north shore of Lake Erie in an area called the Long Point Biosphere. So I think Will earlier vaguely mentioned Lake Lake Erie a little bit and the issues that they have around phosphorus and around other forms of nutrients that have led to algae blooms and other degradations of that Great Lake. And so in the Long Point Biosphere area, there's this collaboration that's been happening between farmers and the local government and with environmental NGOs that have led to a development of a plan where farmers are using their marginal land and they're actually getting paid to use their marginal land on their farms for nature-based solutions. So things like buffer zones, like restored wetlands and things like that. And the farmers have actually started to create a network among themselves where they're getting more and more of their peers involved in implementing these projects on the ground. And so they're able to see how that's restoring the soil in the areas where they're growing these crops, how that's improving the water quality of the streams that run through their land. And it's because of this interconnected way of thinking about agriculture, environment, and water decision-making governance in a very local context to actually increase the positive outcomes that we can see. So that's kind of the opportunity. But something that I think about a bit as the challenge is what happens when we start to put all of these things together and then we all become generalists and we have no more specialists. So we need to think about how specialists are working together and collaborating, yes, but we still need people who are climate scientists and people who are water scientists and people who are ecologists who are really working together on these collaborations and not just saying, hey, all of us should just be generalists who do all this kind of nexus systems thinking together. So I think those are kind of two things that we need to hold in tension as we think about addressing planetary boundaries.
Thank you, I love that. It reminded me of an example we had in the UK once of a water company trying to talk to farmers, and they were basically just using different language. The two of them couldn't understand what each other was talking about, and they just needed to change the words they were using, and it was then the relationship blossomed and they were able to solve problems from that. Anna, going to come to you next. So another topic that's really close to my heart is really about how do we scale and how do we implement and how do we share knowledge. So question for you is, how do we take this current best practice and the knowledge that we've got, because there is so much of it, and use it so that we can increase the implementation of these solutions?
Yeah, it's a very good question. And I just want to say to Leah, I think really important that we also keep the deep knowledge, because we really need it to find the innovative solutions. But what I wanted to say is actually that we need the platform where we can have like a playground where researchers, practitioners, legislators can come together, where we can create the new innovations that can be implemented and become the measurements that are the basic that is really implemented. We can't just only have the really high-end solutions that is only for the few. We need to scale it really on a big scale. So what we have been working with in IVL is the Swedish Water Innovation Center. It's actually not called the Swedish Innovation Center, but it's Sjöstadsverkets Water Innovation Center, where we have built a large-scale pilot facility where we have actually tested most of the technologies now used in the city of Stockholm for the wastewater treatment. We also have built up the digital twins to really evaluate the different technologies, what is feasible, what is not working. So we can really test it in quite large pilot scale before it's implemented into reality, because it's a lot of money put into these investments. So we need to know, is this really going to work? And this is actually the reason why we are now in India and working together with Mumbai municipality with these large-scale wastewater treatment plants, because they were searching, because they want to do the right investments. They want to find the right solutions when they now do all these big investments. So what we really would like to do now is to create a similar innovation platform between Sweden and India. So we're working on a project together with the Swedish authorities here, or financed by the Swedish authorities, called the Center of Excellence, where we will really try to build the same innovation platform, because we think we need to have something sustainable. We can't just have one project after another. We need to have an environment where we can put them all together. So it's not these fragmented projects that we all see. So this is what we are really trying to achieve, and Rupali is here also working with this, of course. But that was actually the reason why we came to India, because of our innovation platform here in Stockholm. Because it's something tangible that they can come and see, they can come and what is happening, what kind of solutions are there already in place.
Absolutely.
Yeah.
And there's a couple of things in there that I just wanted to bring out. The de-risking scaling is so important, because I think we've done really well as a sector at de-risking trials, but de-risking the scaling now is really important. And I think, particularly for CEOs, that's going to be a really fabulous step forward. And also just sharing in motion, we should talk, because there is a site in the UK which is going to be the first net zero wastewater treatment plant, and we're doing the knowledge sharing from that, so we should connect our things
we
up.
should talk more.
Yeah, there's lots of digital twin stuff happening there. Okay, so we now have 9 minutes for questions from the floor. So does anybody have a question for our panel, either the floor or from the virtual world? If there is anything, give me a little wave from the back. No? So we will carry on with the floor. Questions for our panel, please. One down here. Thank you.
All right. Thanks, Anna, and all the panelists. My question is directed to you, Anna. I'm just curious. First, I'm Maganizo Kruganyasul from the University of Oxford. My question is, how open are the systems, for instance, the digital twin that you're piloting in Stockholm, to researchers?
I think that is not really so open, because you know that this infrastructure is becoming more critical for the society. So there is also security risks. So I don't think that it will be very open. But there is also a lot of master students doing work, and this will of course be published. But it is a risk with this infrastructure now. So it's becoming more closed. Actually, it was much open like 5 years ago. So that is a problem. But if you can find the right cooperation, then I think things can be shared on a certain level. That's what I think.
Thank you. We have a question from the virtual world, I believe.
We do. We have even 2 questions. Shall I just go one by one, and I'll give time to answer? First question comes from Helena Alegre. How do you think we can conciliate more demanding technologies, as some of the referred ones requiring scale and expertise, with the pressures to move to distributed solutions for circular economy and resilience reasons? I believe water living labs and as help sharing examples.
Does anyone want to jump in for that?
Well, I think what is important with a lot of new solutions is, of course, bringing them together with the people that need to apply them. Yeah, and then I would say having legislators that remove any barriers for these new solutions to be applied, or even stimulate their uptake. And that's why I think also the water-oriented living labs that Andrea presented earlier can be so useful. Yeah? Because ideally, I think an ideal water-oriented living lab is even operating, I would say, in a context where it is temporarily allowed to break with certain, I would say, policies, legislation, to work to see if those policies that were perhaps created 20, 30 years ago for completely different purposes and now have unintended side effects, yeah, if we could get rid of them, not because we are fighting their purpose, but because we were fighting their current day's effects, whether I would say that cannot stimulate the uptake of these new solutions.
Thanks, Dirk. Yeah.
Yeah, I think that for us at UNEP, we have a very strong commitment to South-South exchange and triangular collaboration. And I think that this element of peer-to-peer learning is really critical, because you then have, these creation of trust and also direct engagement. So we have supported in the past bespoke exchanges where we bring academia together with policymakers and researchers. And I think that in the academic space, I would love to see the living labs also embedded into the education, because ultimately, you know, as more and more people get comfortable with experimenting and pushing the thought boundaries, and also leaning back on indigenous knowledge, because, you know, nature has a lot to teach in protecting us and also cleaning our waters. So I think that this combination between South and triangular collaboration and peer-to-peer exchange is really important. And I think people just need to not be afraid to reach out. I think there's so many people that are available to be spoken to and to connect to. In the previous session, we were talking about mentorship. And I absolutely agree with that. I think it's paying it forward and paying it sideways and really helping collectively to solve this problem together.
Thank you. Should we take the second question?
Sure, absolutely. It's from Professor N. Jaganmatha Venkataramaya. To all panelists, why make the Alps of a mountain of wastewater 500 billion liters and waste a lot of finite resources to treat wastewater, which is just 1% solids? In the earlier WWW 2023 version, Aqua mission at International Space Station, they had a source like a FITS containing wastewater and feces, and to break down simple elements of the periodic table that a high school student is aware of. Can we say the need of the hour is ecological engineering or a closed system? The panelists may enlighten on how to spend less for more benefits.
Does anybody want to take that?
I'm going to leave that to the scientists.
No, I think, yeah.
So I'm a social scientist. So I can't speak to that directly from a technological perspective, and there was a lot of different pieces of that question. But I think part of the question was, if I got this right, what was it to make can you repeat?
The last one, how to spend less for more benefits, or why make the Alps of a mountain of wastewater 500 billion liters and waste a lot of finite resources to treat wastewater, which is just 1% solids?
Yeah.
But maybe I could answer, because I mean, the urban development that we have had globally, it concentrates people in cities, and the flows of these waste and wastewater, all the resources that we need, it creates, of course, this huge problem. So I think, I don't know exactly the question, but I think we really need the industrial solutions for the cities, because it's such a huge problem. So it's not like you can't do like the ecological small-scale solutions in these megacities. I mean, in Mumbai is 23 million? 24 million, and it's like 2.5 times total Sweden. So, I mean, so I think that is the answer from me anyway.
And to briefly add to that, we can think about historical times when people lived in cities and didn't have more technological solutions for wastewater treatment, and how that led to lots of illness and sickness for people. And we know that that is going to lead to illnesses for the environment as well, for animals, for plants. And I think back to what Anna was saying, part of it is the concentration of having so much of that solids all in one place. We're not talking about this being evenly distributed when we think about cities. And so having that concentration is what's leading to potential negative impacts, which is why focusing on wastewater treatment is really important.
Thank you. Okay, I think we've got time for one more question.
Maybe add something about the PFAS and all these chemicals. Then, of course, it's important to get rid of these already. We should not have it in our products or in our streams. So, of course, to work with the legislation for products and product responsibilities is important, because we don't really want to have it in the wastewater streams, because it's very difficult and expensive to take it out from there. So that is, of course, if we talk about ecological, we don't want it in the technical streams.
And I think it links back nicely to this systems approach that keeps coming out in this conversation. So I think we've got time for one more question. Is there one from the floor? Yes, we'll take over here. Thank you.
Thank you. I have a question to Diana. So, when it comes to the reporting framework, the new CSR, corporate sustainability reporting directive. So it singularizes a pollution topic, but then it also intersects with the other topics like biodiversity and water. And what do you think the potential of this sectionalization of reporting framework can improve or help with focusing on pollution, or what could be the benefits of having this setup?
Was it to you? The question was it? Who was it?
Was it Anna or Diana?
Diana.
Diana.
Yes, Diana.
Good.
No problem. Thanks. I think we're working really closely across the board as well. I think corporate social responsibility reporting is a very important trigger. And I think that when we have legislation and rules and regulations that need to be upheld, it's also the responsibility of the public, right, to put their purchasing power where it counts. I think for pollution, indeed, reporting is extremely important, but I also do think that we're moving beyond just the sort of, I would say, the stick. Rather, we're moving towards more carrot, because as the colleagues have said, we're talking about not talking about it as wastewater, we're talking about it as a resource recapture. And I think that that's the reframing, that businesses actually have to have the opportunity and look into the full cycle of their products and services to actually create that circular understanding. And we're seeing it sometimes demonstrated in some cities that are actually looking really dynamically at circularity, and we're also seeing in some different private sector businesses. And once, the perversity of it, but once you create a market, right, that creates then this demand for action. So I think that there's always this balance between creating a market that is also can be a little bit perverse on you get paid if you restore something back, and how do we actually create jobs and create the willingness to actually protect, to not be paid to make it well again, but actually to pay people properly for those important work that they're doing, either upholding our human right to a healthy and clean environment, or also working on the co-joined human right to water and sanitation.
I just want to add something about the CSRD, and because it was now drawn back from the European Union a little bit for the companies. And I mean, it creates a lot of administrative work. And then you can really question yourself, will this lead to innovations and impacts that we really need? Because just in IVL, we had to have 3 people working on this. We're 500 employees. We don't actually emit so much to the environment. But it's such a big administrative burden. So I think we have to be careful on what kind of policy and legislation we put into place. It must be something that drives innovation and that creates real impact. So it doesn't get too administrative. Yeah. But that's my opinion.
No, efficient and effective.
Exactly.
Yes, absolutely. Wonderful. Well, thank you so much to all of our panel members. Thank you so much for the richness of discussion that we've had. Thank you for joining us.
Thank you.
Thank you.
Thank you. Okay, so we have heard some striking numbers and some urgent realities from the discussion and the presentations today, but we've also seen that this story is not only one of decline, it also is about possibility. Innovation is happening, new models of governance are emerging, and there are reasons to stay hopeful. As the writer Rebecca Solnit reminds us, hope is not a lottery ticket that you can sit on the sofa and clutch feeling lucky. It's an axe you use to break doors down in an emergency. That spirit of active hope is what brings us all together here. When we began, we asked you about your own role in shaping the future. And I want to come back to that now because I'm pleased that so many of you chose that collaboration theme, so around supporting collaboration across the sector, because I think that has come out as a real common theme about what we've been talking about today. But the other areas are all equally as important. So my plea for you all is to make one commitment for the next year, whether it's professional or personal, to commit to making some sort of change. And also be public about that commitment. Share it with friends, colleagues on social media. Let's keep this conversation going. For me personally, I'm going to commit to spring innovation, helping to accelerate problem solving by sharing knowledge on the big topics. Specifically at the moment, we are actually collecting innovation intelligence around PFAS innovations. We have 100 solutions that have been submitted in to us. I'll be talking about it again more tomorrow. So for anybody who wants to come back and hear more then, but I'll be committing to share the intelligence that comes out of that towards the end of this year so that we can help accelerate problem solving, not just in the UK and Ireland, but globally as well. So we want to turn this hope into impact, and we want to influence the people with the power to scale solutions. So I just want to thank you all again, both on the online world and in the room, for being a part of this session. Let's leave here with determination, with a sense of shared responsibility, and with that axe of active hope firmly in our hands. Thank you all.